Hi everybody, welcome to this training program on CEA Regulations in Power Systems. I am Engineer J.N. Karamchetti. I am the author of this particular module. And objectives of the modules developed. The author is a qualified and experienced in electrical engineering, power electronics, energy conservation and auditing, design and implementation of solar photovoltaic power plants, to share his theoretical and practical knowledge with engineering professionals to improve their skills and in turn develop India. Now, I think of MV systems, if you see, the diagram is very clear in this. Now, regulation 16 says at the terminals are consumers, premises. Whatever you are seeing on the left side is a power source. Power to the equipment you are doing it, and right side is all the equipment. Along with the three phases or Y, B, here it is represented as a B, C. You have to extend a ground wire also, neutral and a ground wire also to the customer. Customer has to make his own extension and he can provide another grounding on the load side and connect it to the same ground bus. So it is a separate ground bus. They are not interconnected. Every conductor is going from the ground bus itself. The advantage is, in case there is a problem anywhere, the entire ground bus voltage changes, but not that there is a change from equipment to equipment if you connect them in series or loop them, as that is the practice of that. The supplier shall provide and maintain on the consumer's premises for the consumer's use a suitable earth terminal in accessible position at or near the point of commencement of supply. Now, two methods are shown it here. The left side method and the right side method. Right side method is a correct one, where the earthing electrode also is extended from the supply up to the motor terminal, that is the user's terminal. And here earthing of a power transformers and reactors, you can see that a lot of earthing has been done it in this. The basic point I would like to bring in this one is a body earthing, and the second one is the neutral earthing. From the neutral earthing, you have to take a two conductors, independent one, and give it to independent electrodes. This is also one other thing. Second one, this is for the distribution transformer. And this is an example of a DT neutral connection to the earth connection. You can see here that there is a connection coming here independent of that. And surge arrestor close to the transformer, wherever is provided, there can be an earthing from this point, or the body is already earthed, but independently you have to earth it directly taken. To take the full advantage of protective properties of the surge arrestor, the arrestor should be mounted so as to close to be direct shunt relationship to the terminals of the bushing. Earthing of a DTC continued to separate earth wire from LA without any metallic conduit. There is a regulation number 74.2. Minimum three earth pits with a minimum distance of 6.5 meters between them and earth bar to be connect pits. Two earthing leads from the transformer neutral and body radiators cable. That means here two earthing leads from the transformer, one from the body, radiator, cable box, marshalling box, etc. to be earthed. The RMU and feeder pillars or AB switch frame HGDO and fuse frame to be earthed. And supporting poles, distribution box, AB switch handle to be earthed. Here is a single wire earth return where you can run a 11 kV supply up to the transformer, and body of the transformer is connected to the earth. So virtually the voltage will be 11 kV by √3. Cost reduction because of one conductor, less pole top equipment, long and hilltop to hilltop spans, fewer switching and protection devices. Design simplicity, speed of construction, reduced maintenance cost, reduced bush fire hazard, avoid conducting flashing. Now, earthing of a DT in areas of high soil resistivity IS 3043 has prescribed a special arrangement for pole-mounted transformers in areas of high soil resistivity. For such situation, three separate earth electrode systems are recommended. Separate earth electrode at or near the pole to be provided. High voltage metal work, that is transformer tank, support metal works, and the switch framework shall be connected to it. Top of the main electrode should be 225-750 millimeters below the ground. Earthing wire to maintain electrode should be insulated cable from 2 meters above the ground level, so that nobody accidentally put their hand on that ground level. This cable from the bottom of a pole to electrode should be laid 50 millimeter dia earthenware duct filled with bitumen, and earthmat to be provided near the ground surface in the position taken by the person operating the switch handle. Spacing between the earthmat and the main electrode should be minimum 1 meter, and placing a two earth wires on opposite side of the poles. LV neutral electrode system shall be nearer than one pole span away on the LV lines. HV LV earthing connections not to be interconnected. Single wire earth return, whatever I have shown, but here you can see one incoming and two outgoings have been shown. Also in this, what is clearly shown is earthing of HV LV must be separate and independent. This comes under regulation of 48.4. Now, DT is continued. IS Regio suggested the special arrangement for pole. Often in rural areas, earth path resistance is such that the faults are not cleared within a short time. Animals generally congregate near the pole are likely to receive a dangerous shock. In such situations, earth is a neutral conductor at some point inaccessible to animals. Pipe or a rod electrode to be buried with their top of electrode below the ground. Earthing wire to maintain electrode should be insulated cable from 2 meters above the ground level. Now, reduction of voltage gradient over a span of 2 meters from 25 mm dia electrode is all ground level 85% of electrode potential at 0.3 meters below the ground level and 20% for 1 meter and below. Earthing of a pole mounted DTC, you can see many what are the points has been done in this clearly written. This is a REC construction standard which has been fixed, and many people in the REC are following this particular. Provide flexible jumpers thoroughly bridged as shown in the figure. By providing a flexible jumper, there will not be any load on the transformer and neutral bushing. The transformer neutral bushing directly, instead of doing it, you can provide this in between, so that you are getting a two separate connections which can go independently. This is a flexible one. The advantage is the load of the material will not come onto the bushing and doesn't damage the bushing or start leaking the oil. Typical layout of the DTR of earth electrode, you can see there in the equilateral triangle of 6,500 millimeters each, and the DP structure is shown in the blue ones here with a gap of 2,400 between them. Now, earthing of enclosures. Now, how do we do enclosures? Earthing is here you can see that single phase supply is given, but the earth is not extended. In case there is a problem here, and the phase touches the body, and if some operator touches this, he gets a shock, he is standing. So there is a necessity that the cubicle also has to be connected to the earth simultaneously. Here, both are done in this case. One is this, and one bonding conductor has been brought directly from the neutral point to the body, and body is also done earthing. This is IS 3043 stipulates the equipment grounding conductor must present a low impedance path from the frame to the zero. Low impedance is being emphasized, you can notice everywhere. Earthing of enclosures, you can see that delta connected primary, secondary is a star connected, the neutral is earth, and the neutral wire is also brought up to this point but the body is not shown as a earth. The safety ground has come but not connected to this. So it is necessary that the safety grounding should be connected to the body. This is under regulation 41. When the supply voltage is not exceeding 250 volts, where insulations are either new or installations are either new or renovated, all the plugged sockets shall be of the 3-pin type, and the third pin shall be permanently and efficiently. You can see that the third pin diameter is more, third pin length is more. So first is when you are inserting the plug into the socket, first the earth connection is made, then only the phase and the neutral connections are made. This is a good idea. Now, earthing terminal on consumer's premises, whatever is there, this is just like a earth meter. So the meter panel also has to be earthed onto that. And Earthgrid terminals regulation 16 says that consumer premises, the supplier shall provide and maintain on the consumer's premises for the consumer's use a suitable Earthgrid terminal in an accessible position at or near the point of commencement of the supply. Regulation 72.2 says metallic bearer wire supporting the OH overhead service line voltages less than 650 shall be efficiently earthed. That means this is suitable for 433 volts 3-phase in India. Along with the neutral wire, the ground wire also will be regulation 41, where the supply voltage is not exceeding 250, where the installations are either new or renovated, all plug sockets shall be of a 3-pin type, and the third pin shall be regulation 42. Use a earth leakage protective device for instant disconnection of supply on occasions on occurrence of earth fault or leakage of the current. Consumers with a load of more than 5 kilowatts and 650 more than voltage more than 650 and less than 2. Earthing of a distribution lines. You can notice that if it is a, here he has given the earthing as a being a metallic. For a non-metallic or a concrete one, he is taking it around and giving a connection to the cross arm and also to the bottom of the pin. You can see the grounding also here. This is a taken out separate earth connection is given to the ground wire. And earthing of a distribution line, you can see that here cross arm is also connected to this, and this is going to the pin of the third one that is shown it here. And wherever he has given a 2 guy wires also, they also being protected. And inside the guy wire, he has put a stay insulator make off here is provided. So this insulator will isolate between these two, and this is connected to the ground here. You can see that this side, even if this height is a 3 meters in this, even if the buffaloes come and scratch their back here, they should not get there in case there is an accidentally the conveyor has touched this. Regulation 41, the installation and apparatus less than 650 neutral conductor of a 3-phase 4-wire system shall be earthed by not less than 2 separate and distinct connections with minimum of a 2 different earth electrodes. So here see the wording, shall be earthed by not less than 2 separate and distinct connection. That means 2 independent connections has to be given to 2 different earth electrodes to bring the earth resistance to a satisfactory value both at the generating stations and substations. The earth electrode so provided shall be interconnected to reduce the earth resistance. Neutral conductor shall also be earthed at one or more points along the distribution system or the service line. In case of sixth one is, in case of a system comprising of a concentric cables, the external conductor shall be earthed by 2 separate and distinct earth connections. What we call it as a armor also has to be earthed separate. Now, this is the LT earthing systems. Left side is the TN system and right side is the TNC system. You can see that. In neutral wire, this is that in separate. S stands for separate, C stands for combined. So here neutral wire is a different from protective earthing conductor here. Here both have been taken into that. Once you can make it a combined one, you can't separate them out. Now, Earthmat for 33 kV by 11 kV substations, you can notice this. These are all the earth electrodes provided on that. And this is the position for the transformer. From transformer neutral, he has taken one to this side and one to this side. From transformer neutral, first it has gone to the electrode, then to the mat, not directly to the mat. So any fault, first is the earth electrode connected will come into the picture. This is also a similar one as given in the IS 304. Now, various joints of earth mat. When you have an earth mat, what people do is they put a one bolt and leave that here with for the connection. They are putting one bolt. This is not a correct method of doing it. Here it is a it is a overlap. He is providing and welding it. Welding gives a much superior compared to putting a bolt. Bolt can get loose and at any time. This is also T joint in welding. This is a L joint and this is a plus joint. They are crossing each other. So two weldings have been provided on both the sides for giving a firm connection. Now, components of the earthing system, you can see that this tower and this tower, a shield wire is going on the top of this. Below that, we have the electrical equipment. That means in case there is a lightning first will touch this and getting it grounded. It doesn't affect the equipment here. Now, earthing of isolators and auxiliary earthmats, you can see that the body, this metallic portion of the flange here has been earthed with two distinct earth conductors here. And where the operator is standing below that also auxiliary earthmat is provided and connected to the system again. Now, metallic body, in case there is a circuit breakers and the other thing, bottom of the body has been earthed in this case. See that. This is the earth connection. One on this and another one on this sequence. Now, earthing of a surge arrestor is also the same thing in this case. Typical equipment earthing. Anything like a CT you put a PT on this, the bottom flange has to be earthed directly onto that. And again, second earthing is given from this body to be earthed also. It is around 600 millimeters below the ground level. Now, safety of earthing effect, this thing you can see. When somebody goes for maintenance of the equipment, the earth connection has to be given. The first set is connected here, second set is connected here. That means the current carrying conductors have been earthed before the operator, before the lineman gets onto the line for servicing. This is a good practice. Now, where you are not grounding it, ungrounded systems are used. You can have a star delta earthing a transformer. This is the transformer, this is a small auxiliary transformer. And the primary is connected in star and earth. The secondary is connected in delta here. Three connections are why we have been given here. In case there is a ground fault, there is a short. This one has become a short. The ground is connected to this. So there is an unbalanced voltage in this that reflects to the outside. That means we can open it here. It's called a open secondary and connect a relay in between that. This is the same thing, zigzag earthing transformer. This transformer, instead of a normal star connected, it's a zigzag connection is given. That means it will have a one connection here. One is a parallel of something else. Some other phase is also connected. This comes under regulation 4823. In case of a delta connected system, the neutral point shall be obtained by the insertion of a grounding transformer and current limiting resistance or impedance wherever considered. So this system doesn't have a grounded neutral. So this is an auxiliary system. Now, earthmat layout also you can see wherever it is required. Vertical earth electrodes have been provided here at intermediate places wherever. Whereas the fencing also has become a part of the earthing system. The length is 105 and it is 75. This is a grid, that is a strip actually. They are all called horizontal conductors. This is a strip conductor. Measures to lower resistance. Increase in the area of a laying the earth mat. If available, connect with adjacent grounding facilities. So one is increase the area for laying the earth mat, and another one is if available, connect to the adjacent grounding facility. provide a satellite earth grid. That means this earth system can be done at somewhere else, at let us say 500 meters away, and connect it to the main grid. Increase the length of the conductor by laying more vertical rods along the perimeter and increasing the length of the rod. So you can increase the length of the rod by getting into the ground. Reduce spacing between the earth mat and placing of a ground enhancement material around the ground conductor, as we have mentioned in the previous case, is a bentonite you can provide. And concrete and cast electrodes. Concrete is hygroscopic with resistivity of 30 to 90 ohms. Hygroscopic means it absorbs moisture. That is what is required for the electrodes. Satellite earth grid, that means the earth grid is done away from the normal one and a connection is taken from that. That is called the satellite. This diagram has been copied from the CBAP manual 302, and thank them. And this is also from there, as I'm using it only for the training programs. Counterpoise grid in substations. Where inside the substation, if you are not getting a good data at a particular point, this we can use it, especially transformer neutral where you are earthing. If the low resistance you are not going to get it, you can put a counterpoise earth in between a single mesh available. This will reduce the resistance of the grid. Electrode earthing resistance. We are burying one conductor, but please understand one thing. This connection is made here, and this has actually, you can take it as a two connections. The connection should be perfect because this is a current carrying element. And from here to the ground also, you notice that the current flows in this direction, that is along the surface of the pipe. So the pipe should be carefully buried into the earth so that the current can change. Earthing resistance of the electrode is made up of resistance of the metal electrode contact resistance of the soil resistance from the electrode to the infinite. That means the third one is from here going out to some other distant point. Resistance offered by earth, you can see that. As you give a cutting of that, you will understand that when the earth current is going, it is going in the form of a circle. It's electromagnetic one. This is a resistance to the earth of electrode. Now, metals for earthing is they have a galvanic effect of that. Some of them corroded on the negative side and protected earthing also. So you cannot use a gold because it is a costly, it's called as a noble material. So you can use the other material whose voltages are very low. You can use the copper, lead, tin, iron also you can use it. Because if you use the copper, mostly stolen, so you won't be having earth. Instead of that, you can go for the cast iron. Dissimilar metal will have a galvanic cell. That means there is a current flowing between those two metals in the ground itself. The voltage difference is 0.78 volts. Earthing of a cable, regulation 48 for installation of apparatus above 650 volts. In case of a system comprising concentric cable, the external conductor shall be connected with the earth. That is what we are calling as an armor has to be. In case of a system comprising concentric cables, the external conductor shall be earthed at two separate and distinct connections with the earth if the system voltage is less than 650 volts. And earthing of a cable screens and the short lengths of the cables is shown in the circulating current reduce the ampacity. If there is a circulating current in there that heats the cable, and your cable ampacity means carrying capacity of the current comes down because cable is already at a higher temperature. This one is earthing a cable screens and cross bonding of the metallic screens. If the cable is going for a long distance, you have to do at intermediate points. Let us say for a 3 kilometers, you have to do every kilometer bonding, changing of that. This is what we read in other cases as a CTC, completely transposed conductors. In case of a transformer winding, we have noticed. Earthing of a GIS. Characteristics of GES. Area occupied is a 10 to 25% of the equivalent air insulated substations. GIS is gas insulated substation. Equipment are closer requiring high density grid. That means here in this case we have a better insulation, we are keeping them much closer. That is the thing. Here transient enclosure voltages due to lightning strikes, phase to earth faults and discharging during the switching of isolators generate a very high frequency transients than can couple into the grounding system. HF current can cause a local transient potential rise because of the high reactance of the earth connection, because of the high frequency and a discontinuity. And in this case, metal to metal touch system. If they are very close, if there is a fault in one of them, they get a shock because this earthing and this earthing potentials are different. But otherwise, the potential differences between this body and the ground may be more also. GIS, earthing of a gas insulated substation. Basic requirements of a earthing system for AIS and GIS are same. Provision of a mesh arrangement to provide a larger length of adopting mesh arrangement. Connection to reinforced concrete mat. Connecting earth mat to reinforced steel provided in the concrete floor slab also is important in this case. Use of a deep driven rods or chemical treatment of the soil. Frequent and short connections of GIS enclosures to earthing grid. And the connection should be as nearer to the ground level as possible. Use of a non-linear resistance at the locations of the discontinuities. And proper routing of control circuits and screening of control cables and a group of control cables can be enclosed in metallic conduits. Interact and adopt the recommendations of GIS manufacturer. This is always a best thing. You should take the advice from the GIS manufacturer, and he gives a recommendation and puts a stamp wherever has to be earth. He pastes a sticker there, we can follow that also. This is a protective earth. You can see that how much is a big conductor he has provided separately, and a lot of earth connections have been taken from here to each and every equipment available in that particular rooms. This type you can notice mostly in case of software companies. They provide their server in the server rooms. This is provided throughout the wall all around. A protective earthing connection ensures that all exposed conductive surfaces are at the same potential, same electrical potential as the surface of the earth. To avoid the risk of electrical shock, if a person touches a device in which an insulation fault has occurred, it also ensures that in case of an insulation fault, a high fault current flows, which will trigger an overcurrent protection device, either a fuse or MCB or MCCB, that disconnects the power supply. Definitions: equipotential. Two separate points at the same potential, as I have shown you in the other one. The person is touching two different materials. And mesh voltage, it is the maximum touch voltage to be found within a mesh of a ground grid. Transferred voltage, it is a special case of a touch voltage where voltage is transferred into or out of the substation. And arc zone, you can notice here whenever there is an arc is coming and going into the ground, the zone around that will have the electromagnetic effect. Here also shown wherever the zone, the potential at the point of a earth fault will be more in current during the earth fault. The potential is high. As you go away from this 300 meters, the potential will drop down around the electrode. To provide high resistivity layer, as per the Indian electricity rules number 67, touch voltage and step voltage shall be kept within the limits. The ground potential shall be limited to your tolerable values. So any new substation, when you construct it, you should take care of the touch voltage and the step voltage are within the limits. To provide high resistivity layer, the value of a tolerable touch voltage in respect to the human body is less than the value tolerable step voltage. Also, a person in the switchyard may be exposed to touch voltage most often than the step voltage. The touch voltage being predominant must be considered for the purpose of analysis than the step voltage. Like in a substation, the junior engineer goes for taking of the meter readings. At that time, he may be touching the distribution board or the transformer, that is the touch voltage with respect to the ground. To provide a high resistivity layer, following is the formula of a permissible touch voltage. You can see this has got a two things you can notice. One is it depends on the soil resistivity, another is depending on the how long it is happening. That's a T is called a fault clearing time. That means the fuse has to clear or the circuit breaker has to trip. So these two are the touch voltage depends mainly on the two factors: soil resistivity and fault clearing. So our substations setting should be very clear in this case, that fault clearing should be faster. The above formula clearly indicates that it is essential to provide a high resistivity layer under the feet of the person standing in the switchyard so as to keep the value of the touch voltage potential within the permissible. In practice, the touch voltage should be less than 523 volts. The step voltage should be less than 1510 volts. This is the end of part 24, and next one will be soil properties and pocket. Thank you very much.